Welcome all. This is 2018 question number 2, section 2, Strategic Management Accounting past paper. HNDA. A company manufactures the sells 3 different type of product, namely A, B and C. Using the same machinery, the following information available for the next month. They give a table, product A, B and C, and rows, selling price, direct material, direct labor, variable overhead, material, machine hours required per unit, and monthly demand in unit. The available labor hours and machine hours for the next month have been estimated as 11,000 hours and 7,000 hours respectively. You are required to compute the optimal production mix based on resources availability. So let's do the answer. So they have three product A, B and C, and next let's say their selling price. It is mentioned in what is the selling price is product A 8,500, product B 12,500, product C 6,300. Copy that. And next what they say, direct material per unit, we copy that. Next they give us direct labor hours cost in rupees, and 1 hour for 400 rupees. So produce product A, our direct labor cost is 400, so we need direct labor 1 hour. How do we get the 1 hour? 400 divided by 400, it is 1 hour. And product B, our direct labor cost is for one product, it is 480 rupees. So how do we get the hours? 480 divided by 400, it is 1.2 hours we need. And for product C, it is direct labor 320 divided by 400, it is 0.8 hours. Likewise, next they mention variable overhead, it is 400. The same for our product. And machine hours required per unit 0.4, 0.6, 0.3, and is given hours. Now we can with the demand unit, how much they monthly demand, product A 4,000, B 3,800 and C 4,500. Copy that. Next you see the how many hours direct labor hours we need to produce for relevant product. First one, the direct labor A, we need 1 hour direct labor for 1 unit, it is 4,000. It is 1 multiplied by demand unit, it is 4,000, it is 4,000. Next we need a 3,800 unit, so 3,800 unit into 1.2, it is 4,560. And product C, direct labor for one product, it is 0.8 hours, so 0.8 hours into product 4,500, it is 3,600. Next you see for how many hours we available. We available 11,000 hours and 7,000 hours. Labor hours we have 11,000 and machine hours we have 7,000. So we can get the total of our requirement direct labor hours for produce all product. According to our plan, we need 12,160 hours we need totally direct labor hours, but we have 11,000 only. 11,000 only. So so this is the our direct labor is the our limiting factor. So we find the limiting factor, and now we take what is the shortfall. So 12,160 minus 11,000, it is 1,160 our shortfall. So next we get the need MS hours, machine hours, available 7,000 hours. The machine hours we need for produce one A product, we need 0.4 hours. So 4.4 hours into our product 4,000, it is 1,600. And for produce a B product, we need 0.6 machine hours. So 0.6 into 4,560, it is 2,280. And next we need 0.3 machine hours for produce one C product. So we need 4,500 product in C. So 0.3 for 5 machine hours, 0.3 into 4,500, sorry, just 4,500 product, it is 1,350 hours we need. Let's see the total hours we require. It is 5,230 hours we need. Machine hours we need. How many hours we have? 7,000 hours we have. So no any argument with the machine hours, because they are excess amount, 1,770 hours excess. So now we know the limiting factor. Let's see the contribution per unit. How do we get the contribution per unit? The selling price minus direct material per unit minus 400 minus the selling price minus direct material cost and direct labor minus 400 for find contribution. So in product A, 8,500 minus 3,800 minus 400 minus 400, it is 3,900. It is the contribution of product A. Product B, 12,500 selling price minus 6,900 direct material minus 480 direct labor minus 400, it is variable overhead 400 minus, it is 4,720. Next product C, 6,300 minus 3,200 minus 320 minus 400, it is 2,380. So next we can get the contribution per direct labor hour. So our contribution of A is 3,900. We need 1 hours for produce product A. So how do we find the contribution per hour? It is our contribution per unit divided by how many hours, direct labor hours we need to produce a product A. So 3,900 divided by 1, it is 3,900. Next contribution per product B is 4,720. So we need 1.2 labor hours for produce 1 B unit. So how do we get the contribution per hour, the contribution per unit divided by how many hours we need to produce that product. In this case, 4720 divided by 1.2, it is 3933. Next product, like same, 2380 divided by direct labor hours 0.8, it is 2975. So now we can ranking the maximum amount is our best product, the most profitable product. It is in this case 3933, it is rank 1, and next 3900 product A. So product C, it is ranking 3. Now we are going to produce our product according to production plan. First we prepare the production plan. Requirement hours at unit. Available hours, we have only 11,000 direct labor hours. Now first one, ranking 1, it is product B. We need 1.2 hours for produce 1 unit. So our monthly demand in product A is 4,000. So product B, it is 3,800. So 3,800 into 1.2, it is 4,560. So we have 11,000 hours only. So 11,000 hours minus 4,560, it is after produce B, we have 6,440 direct labor hours. Next we ranking product A. For produce product A we need 1 hour direct labor. We plan to produce 4,000 units in product A. So 4,000 product into 1 hours, it is 4,000 hours we need to complete product A units. So after complete unit A and B, we have 2,440 direct labor hours. Next, our target to produce product C. Right. For produce one product C, we need 0.8 hours. So we plan to produce we have only minus 2,440 hours. So 2,440 divided into 0.8, it is minus 3,050. But we have available minus 2,440. So we plan to produce in product A, it is 4,500, but we can produce 3,050 units only. How do we get the 3,050? The direct labor hours, the 2,440 divided by requirement hours for product 0.8, it is 3,050. So this is our production plan. Production plan is we produce from product A unit 4,000 and product B 3,800, and from product C it is 3,050 units we going to produce.